Right, good day. Welcome one, welcome all. We're back again here with the ATP for Mathematics Grade 12 Term 1. From what I'm looking at here, they are saying that the first topic in this year's Term 1 in Grade 12 addresses number patterns, sequences, and series. So now one is to understand what these things are. If you're a grade 12 learner, you may need to constantly keep on checking my page so that you may get some insights as to what you need to be doing in your grade 12 mathematics. I'll come also with other tutorials for those who are doing physical sciences and probably those who are doing life sciences, but at the moment I'm concentrating with those who are doing mathematics. I've started this program for grade 7 up to grade 12. So at the moment I'm looking at the grade 12 work that I have in front of me. It says from week 1, week 2, week 3, week 4 we shall be addressing number patterns, sequence, and series. Then when we go to the next topic we'll be addressing functions. But let us not talk about the next topics. Let's address what is the first 4 weeks of our term 1. Number patterns. What are number patterns? The word pattern in itself gives you an idea of how things are progressing in a certain order. So when we've got a pattern, we have got an order of doing things. We're moving from this to this to this. If you are always absent from school on a Wednesday, it becomes a pattern. So we are talking about number patterns, sequences, and series. By definition, what we refer to as a sequence is a set of ordered values or a set of ordered numbers. That's a sequence. So for the purposes of your grade 12 studies, we've got 2 types of number sequences that we need to look at. The first one is called the arithmetic sequence, and the other one is the geometric sequence. So I'm going to give a brief explanation, a brief orientation into this study. Then after that we get to some examples that we are going to use so that it becomes applicable. Now, when we are talking about an arithmetic sequence, we are having numbers, a set of numbers which are ordered. But the criteria that is used to put those numbers in that sequence is that there should always be a constant difference or a common difference between 2 consecutive values in the sequence. Like what? If I have a sequence of numbers 4, 7, 10, 13, you can see that from each number to the next successive number, I'm adding a 3, a 3, a 3, a 3. And when we've got such kind of a sequence of numbers where there is a common difference between 2 consecutive numbers, that type of a sequence is what we refer to as an arithmetic sequence. Now, have I said something there? Yes, I think I did. The next or the other type of a sequence that we are going to deal with in grade 12 is what we call a geometric sequence. How does it differ from an arithmetic one? In a geometric sequence, the ratio between 2 successive numbers is also supposed to be constant. Remember, when we're dealing with arithmetic sequence, we spoke about the difference between 2 successive numbers denoted by the letter D, small letter d. That gives us the constant difference. But now when we are addressing the geometric sequence, we are saying there is a common ratio between 2 successive numbers in a sequence. That is denoted by a small letter r. So we have got a constant difference in arithmetic sequence, or a common difference in arithmetic sequence denoted by a letter D, and we can also have a constant ratio or a common ratio with the geometric sequence. Those are the 2 types of sequences that we shall be looking at in grade 12. So I'll go and reverse my camera so that I now go to the papers so that we can see what we are talking about. So basically what I was explaining earlier is this. if I have a sequence that has got numbers, let me say 5, then after 5, the next number I write is a 12. After 12, the next number I write, let's say, is a 19. Then you can see that these dots are saying that the sequence continues. If you look at this sequence that we have in front of us, the difference between 5 and 12 here is 7. Why? 12 minus 5 is equals to 7. And the difference between 12 and 19 is 7 again. So as we can see here, we've got a sequence of numbers whereby the difference between two consecutive numbers is common or is constant. It's 7, it's 7. It is not changing. When that is the case, we've got what we refer to as an arithmetic sequence. That's an example of an arithmetic sequence. So this difference I'm talking about, this one, is what we are referring to as a common difference denoted by the letter D. How do you derive that D? How do you get the D? There's a formula to find the D that says the constant difference of an arithmetic sequence is given by Tn minus Tn minus 1. What that simply means is that the next term minus the previous term. So if the next term is term number 3, the previous term is going to be n minus 1, which is 3 minus 1, which means it's t3 minus t2. That gives us the constant difference for an arithmetic sequence. Now, if we are talking about the geometric sequence, we are saying if we have got a sequence that goes like this, it starts with a 2, then after a 2 we get a 6, then after a 6 we get an 18. Then the sequence continues, denoted by those dots. If you look at this sequence now, you can see that if you try to check the difference between the two consecutive numbers, 6 minus 2, that's a 4, 18 minus 6, that should give us a 12. And you can see that 4 and 12 are no longer constant. It's no longer a common difference, which means this one cannot qualify as an arithmetic sequence. But the ratio between two consecutive numbers, so the ratio of 6 and 2 and the ratio of 18 and 6, if you look at them, 6 divided by 2, that's a 3. 18 divided by 6, that's another 3. You can see that the ratio between two consecutive values in the sequence is also common, denoted by the letter R. So now when we have got a situation like this, we now have what we call a geometric sequence. But how do we deduce our constant ratio? The constant ratio now is R is equals to Tn divided by Tn minus 1. What that means is that the constant ratio is given by T, let's say you are saying Tn is term number 3 again, divided by term number 2. If you find out that this value remains the same throughout the sequence, then you can qualify that sequence as a geometric sequence. So that is the kind of work that we are going to look at for grade 12 first term work. Now, after we are done with that, we then need to have some formulas that we are going to make use of to derive what we refer to as the nth term of every sequence, whether it's an arithmetic sequence or it's a geometric sequence. Our next discussion will address that part because TikTok only gives me 10 minutes for these explanations. Until we see each other again, I thank you. Have a good day.